So this is for our triggering test. We are demonstrating that we can trigger on a variety of different signals. What we have probably showing you is we have a function generator set to 10 kilohertz, square wave, no DC offset. The duty cycle is set to 50% now, so it's just a regular old square wave, and we are at 20 volt peak to peak as shown on the TriggeringTest oscilloscope. And that signal is being fed directly into our oscilloscope, which is communicating back with the computer, and you can see there. And here, I'll play with it just a little bit, play with the frequency so you can see that this is actually live updating. You can see it stretch and shrink. That is a 20 volt peak to peak square wave that we are triggering on. Now we're just going to cycle through all the other options. There's a triangle wave we're also triggering on. There's a sine wave. And now we're going to go back to the square wave. We're going to lower the amplitude to the next lowest value that we need, which is 10 volts. So here is 10 volt peak to peak. You can see on the both our oscilloscope and the TriggeringTest oscilloscope that we are now at 10 volts peak to peak. A little low actually. And we go back. There we go, 10 volts. And we can cycle through again to show both a triangle wave and a sine wave here. There's the square wave. There's the triangle wave. There's the sine wave, and we're triggering on all three. Now we can cycle through the voltage again, lower the voltage to 5 volts peak to peak, and let's see what we got here. Right about 5 volts there. Yeah, okay, close enough. Now we're going to show that we can trigger on 5 volts peak to peak, and you can see already we're triggering on the square wave 5 volts peak to peak. Here is triangle wave, and there is a sine wave. We're triggering on all three, so we're still good to go. Next voltage that we need to show is 1 volt. So for that, I'm going to switch over to the 0 to 2 volt peak to peak setting. Well, you didn't lose it there, did you?
Nope.
Okay. Looks like. And 940. That was close. Alright, so there is basically 1 volt peak to peak coming out of the function generator. And as you can see, we're still triggering on it. That's a sine wave. There's a triangle wave. And there's a square wave, and all three look good. And we have successfully triggered on all of those options.
Yeah, why not? This is the toughest option to trigger on right now, is the 1 volt that we're going to be doing for the moment.
Right. So here is, we need to also play with the duty cycle a little bit to show that we can trigger on different duty cycles and square waves. So I'm just going to sweep through a bunch of frequencies here and show that we trigger on all of them. Here, I'll do it once for the tech scope so you can see how the duty cycle goes all the way up to right around 90% there. In fact, it is 90% now. And we can go back down, and you can show them on our scope now what happens, the same deal. Still trigger correctly on that rising edge. And all the way up to same place, 90% duty cycle again. Oh, even further. Oh, okay. The scope doesn't like that. There we go. There we are. Okay, that's as far as the duty cycle will let us go, right at 90%. We can set that back to 50%. Do we need to show both rising and falling edges now?
We can do that, sure.
So now we can go to falling edge. Do we need to cycle through the same options? I suppose we probably do.
Sure. Let's go through. So let's try the duty cycle first.
Okay. Yeah. So here's
on the
again.
neck.
Now we have switched everything over to triggering on the falling edge, which is just the opposite of the rising edge. So it should be really straightforward as we go through it. This is again the 1 volt peak to peak square wave, and I'll just play with the duty cycle again to show that we can still trigger on the falling edge of a square wave with a low duty cycle. And I can raise that back up. Now I'll show you triangle wave, 1 volt peak to peak triangle wave, falling edge we are triggering on. And there is a sine wave, so we can do that. Now we're going to up the ante a little bit. I'll switch it over to, that is, hold on 1 second, okay, we're a little low here. You can see we're back at 5 volts peak to peak on the TriggeringTest oscilloscope, and now we are successfully triggering on a falling edge on our scope of the sine wave. We can change it to triangle wave, which we have there, and square wave, which we are still triggering on the falling edge of. So now we can increase the voltage up to 10 volts peak to peak. We can, let's see here, right around 10 volts, there we go. And lower the programmable gain amplifier. There we go. We can see that we're still triggering on the falling edge of that square wave. There's the triangle wave, still triggering on it. And there's the sine wave, we're triggering on all three of them. Now, for our last little bit here, we're going to go all the way up to 20 volts peak to peak. And trigger on all three types of those waves. There's 20 volts peak to peak. Almost exactly, that's nice. And we are still triggering on here on the falling edge of that sine wave. Show you the triangle wave, and there's the square wave. And Kavi, do you want to show them maybe that we can change the trigger level and have the Kavi's going
to go back to the
Kavi's going to change the level at which we're triggering, so you can see the wave move sort of left to right as we're triggering a pretty low value in the wave, now a pretty high value in the wave, and somewhere in the middle now. And there's a bigger gain, so maybe you can see a little bit more of how that moves left to right. So we can adjust the trigger value to whatever we want, basically trigger wherever we want on the wave. And also, as we already showed you, rising and falling edge. There's the rising edge, and we can keep shifting that wave back and forth. Is that all we need to show for this test?
I think that'll do it.
Alright, so that is at least part of the triggering test. We're going to have to make another video to show you the 50 volt peak to peak and 25 volt peak to peak sine waves, as well as the 50 millivolt square, triangle, and sine wave.